Discuss LeetCode problem number 4, hard problem, median of two sorted arrays. But before we discuss, please share, like, subscribe, and hit the bell button for notifications. Also, I have added a lot of quizzes to the community page. Please check it out. Now back to the problem. Like, you are given two sorted arrays, 1, 3, and 2. In this case, like, you need to calculate the median of the two arrays. It's as if like you merge them and then you calculate the median. Median is always the middle number. It is not the average. So in this case, it could be like 1 billion, and then the median is still 2 because the billion cancels out the 1. And also the overall time complexity should be log of m plus n, which basically indicates some clue that you need to use binary search somehow in this solution. So let's take a look at the solution. So I call this as a binary search partition pattern. So the overall strategy is to basically partition the left 4 partitions if possible, unless there are some extreme conditions, means extreme cases, edge cases. You can partition the left first nums1 array into left and right, nums2 into left and right, and once you are done with that, then you can calculate the median. So because the way you partition the into the left partitions is through using binary search, and that's the reason why binary search, and there are 4 partitions unless there are edge cases. So that's why I call it as binary search partition pattern. So let's take a look at the code. If nums1 is greater than nums2, you swap it, because you want, if you're doing the binary search, you do the binary search on the smallest array rather than the big array, so to get the efficiencies. And so m is the size of nums1, n is size of nums2, and then you calculate the total left. Total left is like in the median, right? Half the elements are to the left, half the elements are to the right. So just calculating total left is good enough, because once you calculate total left, you know what the total right is. And so you start off left equals to 0, right equals to m, the binary search logic, and left is less than or equal to right. You calculate the middle, and then you calculate j as total left minus I, because I is the middle of nums1 and j is the middle of, not exactly middle, basically j is the where the left partition, where it is, where the nums2 is being partitioned. Let us put it that way. I is where nums1 is being partitioned at, and j is where num2 is being partitioned at. So you calculate these values. What are the nums1's left max, nums1's right min, nums2's left max, and then nums2 right min. So left max and right mins, they are the ones next to each other, and that's where the median exists. So that's why we calculate this. And how we calculate this is left max is, let's ignore this int min and int max for a while, and nums1's left max is nums1's I minus 1, and nums1's right min is I, and left max is j minus 1, and nums2 is j. So that's where it's being partitioned. So that's how you calculate left min. Now you want to make sure if your partitions are right. If they are not, then you use the binary search to actually move the partitions. And so nums1's left max should be less than nums2's right min, and then nums2's left max should be less than nums1's right min. If these two conditions are satisfied, then we have the exact partitions. and let us assume we do have the exact partitions. Then the way you calculate the median is if this is telling whether the total number of elements are odd or even. If the total number of elements are odd, then you know there is a middle element. So if it is 11, there is 5 on the left, 5 on the right, and the sixth one is the median. And so you calculate the max of nums1's left and then nums2's left. Whichever is the max, if you club them, that actually becomes the median. And in the case of even, you calculate the same as this one, but also you calculate the minimum of both the rights. And so maximum of lefts is the left partition's max element if you club those two arrays, and right minimum of the right two rights or the uh, minimum element from the right. So that's where they're right next to each other, and that's where you need we'll look at it with an example, and that's where you need to do these two divided by 2 is what becomes the median. And if they are not exact partitions, then what happens is if nums1's left max is greater than the nums2's right min, so then you move right to I minus 1. Otherwise, you move left to I plus 1. So we will take this with an example of this example, and then I'll come back to this code to explain more clearer. So initially this one is 5 and this one has 7 elements. So left starts off with 0, right starts off with 5 because of m is 5 and I is 2 and then j is 4. Total left is 11 divided by 2, which becomes 6, and so that's what 5 plus 7 12 divided by 2, that is 6. So now you calculate nums1's left max, I minus 1 is 3, nums2's right I, which is 8, nums1's left max is basically j minus 1, so it is 19, and then nums2's right min is 21. So this is the partitions we have, but if you see nums1's left max is 3 is less than nums2's right min is 21, and nums2's left max is 19 and nums2's right min is 8. So this condition is not satisfied. So you will come here, nums1's left max is 3 is greater than nums2's right min is 3 is greater than nums2's right min is 21. So basically we need to move the I to the right, so left becomes 3, and so you are moving the partition originally was this for the left partition of the left one, so now you are moving that into this one. And so now once again you calculate nums1's, actually you are moving, the original partition was this 138 and then you are moving it into 1389. So nums1's left max is 9, nums1's right min is 15, and nums1's left max is 11, I equals to 4, so that one's j becomes 2 actually. So j becomes 2 and j minus becomes 1, and so left max becomes 11 and nums2's right min is 18. So now the conditions are satisfied again. So nums1's left max is 9 is less than nums2's right min 18, nums2's left max is 11, nums2's right min is 15. So we got the exact partitions. So there are odd elements. Median becomes, if medians is nums1's left max, basically the max of these two, 9 and 11. So 11 becomes the median. And I think I forgot to add this one. The int min and int max is needed. Say for example, the left is 0. There is no elements. The size is 0, and then the nums2 is 2, 4, 6, I'd say. So I becomes 0, and when I becomes 0, then you need to make sure nums1's left max is less than nums2's right min. And in order to make sure, then what happens is int min is less than whatever is the value. I think in this case it could be 6. Nums2's right min is 6. So int min is less than right min. So in order to handle those edge cases, you need this int min and int max based on whether it is the left edge or the right edge. And comment below if you have any questions. Otherwise, I will see you in the next video. Bye.